Hello again. I'd like to show you a demonstration of refraction and internal reflection using PowerPoint. You can do this using just paper and pencil. In this case, this PowerPoint example is maybe a little bit quicker. So what we will do is start off with a polycarbonate lens right here in the middle, and we'll just assume a single wavelength of light. The full spectrum of wavelengths, the angles will be slightly different, but if you're shining a white light, you get a little bit of spread towards the light exiting. But this is going to just show the proof of the concept. So we start off with the index of refraction for polycarbonate. I found this online. Then we have air index of refraction, almost equal to 1. So what we're going to do is start off with a set of lines here. In this case, I basically draw a few lines like this, and then we'll draw a few more to get you a total of 4, 5, and 10. Then we will use the distribute horizontally. I have it on my quick access toolbar, and we group them, and then you can just set them along your material wherever you need it to. But that's the basic concept of how to get equal spaced. Then if you want to get even more accurate in between, since we're dealing with some tight decimals, you could take that same set of 10 lines and then line them up between these other major lines. So it's a good quick way to get some accurate increments if you need. So the first thing we'll do is, with the air, we draw a circle from this center point. This is going to be where the light comes through, whatever angle of incidence we have. Then the next line will go through the angle of incidence of where what the polycarbonate is, so 1.58. So then we'll start off drawing a line that's the same, whatever direction of incident light, and we'll go through that center point of the circles. This first angle to the vertical is going to be theta I, incidence angle. So where that light goes through the center, and wherever it first crosses the air index of refraction circle, then you will draw a vertical line through there. And it's easy with PowerPoint. You would just hold shift and draw your line. It locks it in to vertical or horizontal, and then you can shift it over to that exact position. Then you will, in this case I just drew a darker blue line for reference. You'll draw from that vertical line, you draw a dot on the polycarbonate index of refraction circle, and from there you connect that dot to the first dot where the light entered into the PC. Then the angle here, theta R, is the refraction angle that happens because of the different index of refractions. And that is all summarized in Snell's law. You can look that up online or look at the formula here. But this angle away from normal, in this case, is 26.5857. So that's the path that the light will take when it enters the polycarbonate, and it will keep going that direction until it enters a different, or meets up with a different medium with a different index of refraction. So then you can see I'm going to take that same set of lines. I colored them red for this comparison, but you move them from that first point down to the second point. Then from that point, we continue the line down to meet the polycarbonate index of refraction. And actually I would copy these down if I needed, but I'm using the same orientation of the concentric circles, so I just left those lines there. You draw another dot and another vertical line. Then where that vertical line meets up with the air index of refraction, you will draw from this exit point from the polycarbonate to the air, draw another line to that next dot. That's going to show you from where that light entered, refracted, then exited, refracted again to the air medium. So then you would have the theta r is, plug it back into Snell's law, get that angle if you needed. Then this slide is summarizing, showing with the gray circles and the red circles the incidence light at this angle, then it will refract at this angle. Then when it exits the polycarbonate, again it will refract because it's a different medium at this angle. So as I mentioned, if you were to do this with different wavelengths, you would see that there would be a slight split of blue and red light, and then when those come out, there'll be a slight wider split. So that gives you an idea of what the light would be doing. Then for a separate example, I did a different angle of light. It would refract down, same method, and then come back out. There will be some limitations when you get to certain angles, but this is just showing the proof of concept. So another fun exercise I did was I had noticed that some mirrors with glass or polycarbonate, they would have multiple reflections. So in this case with this candle, it's reflecting, and you see two reflections off of there. On this coffee cup and saucer, you can see multiple reflections. This first reflection here, a second reflection, and then even a third reflection, really faint on here. And so I was curious how much light was actually being lost. So I did the same exact exercises on those previous slides and showed the light entering, refracting, exiting, and then, but some of that light is being lost. There's another formula for the percentage of reflected light and percentage of refracted light. So going through those calculations to show the amount that's reflecting internal reflection, and then how much is refracting back out, much smaller percent that you can see here. And you can do your own calculations for whatever materials you are using. So that's why each of these multiple reflections is much more faint than the previous one. And I had just another couple slides showing with different prisms, shapes, how the light will refract and then also internally reflect once it hits the critical angle. So you can look at a little bit more online at the total internal reflection. I got this from a physics website, and just some references of index of refractions, and then some more detail about the critical angle, which I won't go into that detail here. Then another fun app that I had found was from a Colorado EDU simulation bending light. You can do the same kind of study using kind of a laser looking device, white light, and then through a prism how it would actually split that light like I had mentioned. Or you can pick just a single wavelength. You can also do, with one of the options, do multiple lines of white light, so then you would see much wider split. So that's the summary of how to show refraction and internal reflection using PowerPoint. If you have any questions, feel free to contact me. Thank you.